All right, so now we're going to look at finding asymptotes. There are three kinds of asymptotes: vertical asymptotes, horizontal asymptotes, and slant or oblique asymptotes. So we're going to look at each kind and then we'll put it all together at the end. Okay, asymptotes, first off, only happen when we have a rational function, meaning we have a function that is a fraction. That's when we're going to have asymptotes. Okay, so let's look first at vertical asymptotes. Vertical asymptotes, you must write the answer in x equal a, x equals some number format. A vertical asymptote is a vertical line. Okay, it is a line that goes on and on forever. It is a vertical line that your function will never cross. Okay, now vertical asymptotes, when we find them, it's very much like when we found domain. They are very closely related. The only difference between finding the domain of a fraction and a vertical asymptote is that we can simplify the function first. When we find vertical asymptotes, we need to simplify the function first and then set the denominator equal to 0, where in domain we do not simplify. Okay, so that's the difference between the two. Let's go ahead and look here at an example of a vertical asymptote. So let's find this vertical asymptote. So we're going to set the denominator only equal to 0, set x cubed minus 16x, let's set that equal to 0. We can factor an x out of both of those terms, so we have x times x squared minus 16 equals 0. Now, let's keep factoring. So we have x times, and this part factors to x minus 4, x plus 4. Set each one equal to 0. So I have x equals 0, x minus 4 equals 0 means x equals 4, x plus 4 equals 0 means x equals negative 4. So those are our three vertical asymptotes. This problem would have three vertical asymptotes. Let's go ahead and look at horizontal asymptotes. Horizontal asymptotes are going to be a horizontal line. Again, we need to write them as an equation. So they need to be y equals some number. Okay, so remember, vertical will be x equals, horizontal will be y equals. We can have our graph cross a horizontal asymptote. Usually doesn't, but it can. Now, horizontal asymptotes is very important to note. Horizontal asymptotes occur when the degree of the numerator, the top, is less than or equal to the degree of the denominator. Okay, so I'm going to give you two examples. So if I had x squared minus 6 over x squared plus 3. That would be one example of when we would have a horizontal. Here's another example, x plus 1 over x cubed minus 7x. Okay, the degree in the denominator is bigger, or the degrees are the same. That's when we have horizontal asymptotes. All right, finding horizontal asymptotes. Okay, so what we're going to do is divide everything in the numerator and the denominator by the biggest degree in the denominator, which is the x squared. Okay, so I'm going to rewrite this. So we have 3x squared plus 2x minus 4 over 2x squared minus x plus 1. Let me fix that. Squared. Okay, now we're going to divide by x squared, divide by x squared, divide by x squared, divide by x squared, x squared, and x squared. And then let's simplify. So those are going to divide out. So we're going to be left with 3 there. That divides out. So I'm left with plus 2 over x minus 4 over x squared. On the bottom, I have 2 minus 1 over x plus 1 over x squared. Okay, what we're going to do with this is take the limit the limit as x goes to infinity. So I want you to think about this. And let's start with the simplest fraction we have. Let's start with this one. So we have 1 over x. So let's say this 1 represents 1 pizza. And we have x people sharing it. So let's say it starts out 4 people. That seems fine. Each of us gets a quarter of the pizza. Okay, what if we make that bigger? What if 20 people are sharing the pizza? Your piece gets a little smaller. What if I make x even bigger and I say 1,000 people are sharing the pizza, or 1,000,000 people are sharing the pizza? At some point, this feels like you're getting no pizza, right? So anytime we have an x on the bottom of a fraction and we are making x go to infinity or get really, really, really large, those fractions are going to go to 0. And what we are left with in this case is y equals 3 over 2. So that would be our horizontal asymptote. I want to do another example. Let's see. So let's say we had x plus 1 over x squared minus 6x plus 2. Okay, so here we're going to divide everything by x squared. So we're going to have x over x squared plus 1 over x squared over x squared minus 6x over x squared plus 2 over x squared. All I did was put everything over x squared. Okay, so here, if I simplify this top one, I get 1 over x plus 1 over x squared. On the bottom, I have 1 minus 6 over x plus 2 over x squared. All right, if I take the limit as x goes to infinity, this one goes to 0. 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 Anything with an x in the bottom, when I make x get really large, is going to go to 0. So I'm left with 0 on the top and 1 on the bottom. And 0 divided by 1 is still 0. So for this one, it's y equals 0. I want to take a look at these, though. Tell me about the degree in this problem. How did the biggest degrees compare? In this first one, they were both x squared, so they were the same. So there is a shortcut. When the degrees are the same, our answer is a ratio of their coefficients, right? The 3 was the coefficient in the numerator. The 2 is the coefficient in the denominator. So it became y equals 3 over 2. That was our horizontal asymptote. In the second one I gave you, the degree in the denominator is smaller, or the degree in the numerator is smaller, or the degree in the denominator is larger, however you want to say that. Okay, the top is 1 less than the bottom. So anytime the degree in the top is less, doesn't matter by how many, anytime the degree in the top is less, we're going to go straight to y equals 0. We don't have to do all this limit stuff. Those are the two shortcuts. If the degrees are the same, it'll be a ratio of the coefficients. If the degree in the top is smaller, then we will go straight to y equals 0. All right, your next type of asymptote is called a slant or an oblique asymptote. I'm going to start with the bad news. The bad news is there is only one way to find a slant or oblique asymptote, and that is by dividing. So we're going to do polynomial long division and divide these out to find out what the slant asymptote is. Now, there is some good news, and that is that it only happens in one very specific instance, and that is when the degree of the top is exactly 1 bigger than the degree of the bottom. Okay, so it only happens in that very specific instance. And let's go ahead. I think we have an example coming up. Yep, here we go. So let's find the slant asymptote for this. And I want to start, actually, let's go back. I want to insert a page. Okay, so let's start with something that we know. 8, let's see, 624. Okay, so going back to long division when we were kids. All right, so there are steps. Compare. That's what I call the first step. That's where we look at the problem. We go 8 goes into 6. No, it doesn't. 8 goes into 62. Okay, it does. So I put a 7 up there because that's how many times it goes into 62. Step 2 is to multiply that 7 by the 8. Okay, so 7 times 8, we get 56. Next step, what do you do next? Subtract. So I'm going to subtract 56 from 62, and I get 6. And then the last step is to bring down. Okay, so I brought down that 4. 8 goes into 64, 8 times, multiply, subtract. Okay, so compare, multiply, subtract, bring down. Write those steps down somewhere because we are going to use those same steps to do our polynomial long division. All right, so let's go ahead and set this up. So we have x minus 3, and we're dividing it into 2x squared plus x minus 1. Okay, now one slight difference in our compare step. We're only going to compare the first things. We're not going to worry about the other terms on the end. So x to 2x squared. One way that some students like to think about this is, if I had to multiply this x by something, what would I need to multiply it by to turn it into 2x squared? Okay, and the answer is 2x. Okay, so now let's go to the multiply step. Multiply 2x times x, so that gives me 2x squared. 2x times negative 3 is negative 6x. Okay, the next step is to subtract. We are subtracting something with multiple terms, so make sure to change both signs. That first one should add to 0, and I have x plus 6x, so I have 7x. And now we're going to bring down the minus 1. Start all over again. X to 7x. What would I need to multiply x by to turn it into 7x? A positive 7. So 7 times x is 7x. 7 times negative 3 is negative 21. We're subtracting, so change both signs. So that adds to 0. And we have a remainder of 20. Now, the nice thing for our slant asymptotes is we don't have to worry about how to write the remainder or what the remainder is, because this portion gives us our slant asymptote. Okay, so that's polynomial long division. There are videos out on YouTube if you need more help with polynomial long division. All right, this is the way you will usually see my problems for asymptotes. It will say find all asymptotes. And what I expect you to do is write down HA, VA, and SA. Now, by definition, since a horizontal asymptote happens when the degrees are the same or the top is less, and the slant asymptote happens when the top is 1 bigger, I can't have both at the same time. So let's start by figuring out which one I don't have. Degree in the top is bigger than the degree in the bottom by exactly 1. So I do not have a horizontal asymptote. I am going to have a slant asymptote. All right, now step 2, let's solve for the other two. So slant's the hardest, so I'm going to go to vertical next. X minus 1 equals 0 means x equals 1. So there's my vertical asymptote, x equals 1. And my slant asymptote, I'm going to go ahead and do the division. So I have x minus 1, x squared. minus, now this one is missing a term, so we need to go ahead and put a placeholder in there, and we can actually put that as a plus, minus 4. Okay, I have to have a place to write my single x's. All right, so x times what gives me x squared? X times x. So x times x, that's x squared. X times -1 is -1x. Now, if I hadn't put that 0x there, we wouldn't have had a place to write that. Okay, change both signs when you're subtracting. So we have x, bring down. Okay, and then we're going to start over. X, what do I need to multiply by to keep it x? Well, we'd multiply by 1. So 1 times x is x. 1 times -1. Okay, subtract, so change both signs. And we have -3 as our remainder. So this is y equals, our slant is y equals x plus 1. Okay, so that is our answer for all the asymptotes for this particular problem. And our last one, again, HA, VA, and SA. And let's look at those degrees. Where is the degree smaller? Smaller in the top. That means horizontal is y equals 0 and slant is none. We answered 2 of them at once. All right, vertical, x squared minus 7x plus 12 equals 0. We need to factor that, so I need two numbers that multiply to 12 but add to 7, x minus 3 and x minus 4. So I'm going to have x equals 3 and x equals 4. So those are my asymptotes for that particular problem. And that is everything for today. So practice those asymptotes.